Hi, welcome back to the Virtual Elephant YouTube channel. I'm Chris Muchler, Fractional CTO and Principal Enterprise Architect. In this video, we're getting back to one of my favorite subjects, Cilium with Kubernetes. I'm going to show you how to leverage Cilium's BGP functionality to be able to deploy it in a production environment, as well as its Gateway API functionality to allow for ingress inside of your Kubernetes clusters. This video is going to demonstrate how you can advertise dynamically allocated VIPs all the way up through your physical network and physical infrastructure to allow your applications to be able to leverage everything that Cilium has to offer. Let's jump in and let's get started. With the most recent announcements around the deprecation and retirement of the NGINX Ingress Controller from Kubernetes, many organizations are faced with a challenge. How are you going to be leveraging Ingress into your applications going forward in 2026 and beyond? Now, in the past, I leveraged both the Ingress controller through NGINX as well as HA proxy. And the NGINX Ingress Controller is even the default if you're using Rancher, which you've seen some of my videos where I demonstrate how to do that in the past. But moving forward, we need to be able to adapt with the times and to be able to change as things within the CNCF ecosystem change as well. And Gateway API really is the next evolution of what we want to be able to offer to our applications from an ingress and even egress perspective. Now, Cilium, if you're using it for your CNI already, is going to make its adoption very easy. And in this video, I'm going to demonstrate just how easy it is to get not just the BGP side of things up and running within your Cilium-based controllers and Kubernetes cluster, but as well as the Gateway API functionality. And I'm going to show you how once I get the BGP functionality running, I'll be able to immediately deploy a Gateway API object for Hubble to be able to have observability into my Kubernetes cluster. Now, I'm already doing this in my new cloud-based hardware server, my Supermicro cloud server that I'm running Kubernetes on, that I am considering production for my needs. It's actually running several internal and even external applications that I've written over the last year. And one of the things that I've learned as I've gone through this process in the last few months is how easy it actually was to adopt Gateway API. Now, change is hard for everyone, including myself. I can remember in years past when various technologies have changed and I was hesitant to adopt the latest technology that the industry was moving towards. But I can say with confidence now that moving towards Gateway API was really a no-brainer in the end. It's made things much easier for me, and it's allowing me to be able to apply policy and security policies specifically to my Kubernetes clusters, all within Cilium and YAML code, which makes things very easy from a GitOps perspective. And so all of this is really starting to bake into one another as we build out these very mature Kubernetes clusters. So very quickly, before I show you how we're going to actually be implementing both the BGP functionality as well as the Gateway API, let me first direct your attention to the screen. On it here, you can see a Grafana dashboard for my bare metal Kubernetes cluster where I'm already running all of this functionality. And in today's video, I'm going to be demonstrating to you how to do it through a set of virtual machines that I've spun up and will be configuring live for us during this video. But really what you can see here is that I have a bare metal Supermicro blade server that has 8 blades in the back of it and that I've configured Kubernetes on top of. And again, this is where I'm running many of my production applications. And when you've seen my Argo instance and some of the things that I've been doing with GitOps in the most recent videos, all of that work is being run off of this Kubernetes cluster. But we're going to basically be jumping into a VM-based cluster that I'm going to show you how to configure. Now, the first thing that we want to do is we want to be able to leverage BGP to be able to make the dynamic /32 routes that our Gateway API objects are going to be creating. And so we're going to need to pair our Kubernetes cluster to our physical network. And so I'm doing that on a set of Cisco Nexus 3360s that I have running in my spine leaf topology. So my 2 leafs are also my border leafs. So they're responsible for all of my north-south traffic going in and outside of my environment. Now, once we've deployed Cilium, one of the things that we're going to do first is we're going to create an IP pool. Then we're going to be creating and deploying the various components for BGP. And then once we've done all of that, then everything will be enabled and we can actually deploy our first application with an ingress object that actually is a Gateway API object. I've gone ahead now and I've actually deployed a VM-based cluster, Kubernetes cluster within my environment. Now, this cluster is running on a port group that is just tied to a VLAN on my physical network. So regardless of the medium that I'm using, a virtual machine here, the setup steps for what we're doing here is exactly what I did within my Supermicro server. So you can see here on the screen that I have 8 Kubernetes nodes that I've gone ahead and deployed. I've also deployed a load balancer. Now let's be very specific. This load balancer is running HA proxy, but it's only being used for the API service in Kubernetes. This is not handling any of the traffic for the applications themselves that will deploy within this cluster. And so this load balancer is actually only configured to talk to the controllers on port 6443, and that's it. Now, in this cluster, I've designated node 1, node 2, and node 3 as the controllers, and then nodes 4 through 8 are the worker nodes. Now, the great thing about leveraging BGP directly off of the nodes themselves means that regardless of how large our Kubernetes cluster gets, whether it's a few dozen hosts or a few hundred or even a few thousand, we're going to be able to leverage BGP across it. Now, we're going to be leveraging equal cost multipathing or ECMP within the environment for BGP. And if you're unfamiliar with equal cost multipathing, or you just want to have a deeper dive into BGP, I encourage you to check out my BGP deep dive video that I published a little over a year ago as part of my networking series. It's a great foundational piece for you to learn a little bit more about BGP. And we're really not going to be going over any of the specifics or basics of BGP. I'm just going to assume that you know what we're doing here. But one of the great things that we're going to be doing with this Kubernetes cluster is that we're going to be specifying a specific number of the nodes to actually act as BGP nodes. And we're going to do that through a label on the node itself. And then once the label is there, we're going to actually tie it to part of the deployment for the BGP cluster policy that we're going to set. So in your environment, it's going to vary on the number of nodes that you want to deploy. In this environment, we're going to be deploying 3 of the nodes or setting up 3 of the nodes as BGP peers with the upstream leaf switches that I have running on the physical network. But really, you're going to want to have anywhere between 2 and 8 of these nodes within your environment. You want to at least have 2. You don't want to have a single point of failure by only running BGP off of one node. But once you've decided on the number of nodes, once we do that, then we're going to go ahead and walk through the configuration. Now, a few things to take into consideration as you're determining how many nodes within your Kubernetes cluster you want to run BGP. It's really going to come down to how you've configured the cluster. Is the cluster spread out across multiple racks, multiple rows, maybe even multiple data halls or colo floors within your data center? Once you've determined that, then you can come up with a policy to determine how many you want to have. And you probably don't want to have any more than 8 because every node that you configure, you're also going to have a configuration piece that ties into it on the physical network layer. So obviously, if you don't own your physical networking layer and you're going to rely on a network engineering team, perhaps to do that configuration, it's more than likely that they're going to want to keep the number of nodes that they're pairing with to a relative few. So you can see here, this is the vSphere view. We're going to jump right into it. Before we do that, I want to just talk about Project SignalWave. So within Project SignalWave, I have an install document for Cilium itself that I keep up to date. And it has been updated for the instructions that I've used to already deploy Cilium within this Kubernetes cluster, as well as the steps that we're going to take today as part of this tutorial video. So if you look here at the install guide inside of the project SignalWave repo, you can see here that I am installing Cilium through Helm. I'm installing 1.18.2. Now, some of the options that you can see set here are probably very familiar to you. Things like enabling Hubble, enabling the Hubble UI, specifying the metrics, as well as Prometheus. What might not be familiar to you are these last set of commands, which is enabling the BGP control plane, installing the CRDs, as well as enabling the Gateway API functionality, making sure we set the gateway class, as well as these L2 announcements, and replacing the kube proxy and setting that value to true as well. Now, this is going to be a very easy command to run within your environment or used within your deployment views, depending on what tool you're using to deploy your Kubernetes clusters. If you're using Rancher, you're going to have to do some tweaks inside of Rancher to be able to get this functionality deployed the way you would expect it to be deployed. Now, the other thing to call to your attention is this line here. So there are a number of CRDs that we need to make sure are installed and in place prior to us enabling the BGP and the Gateway API functionality inside of Cilium. So you want to make sure that you go out and either just download this YAML file or do as the command here shows you and just apply it directly through kubectl within your cluster. Once you've done that, then you're going to be ready for the Hubble, for the Helm command itself. And then you can see here, I walk through what we're going to talk about next, which is how you actually configure BGP, and then how we apply the Gateway API to the Hubble UI as well, which we'll do towards the end of this video. So you can find all of this information in Project SignalWave on my GitHub repo. If you haven't checked out this repository, I encourage you to star it or fork it if you need to. I keep it updated with a number of things that really I cover in these videos. It's kind of becoming my all-inclusive source for all of the information that I do on YouTube as it relates to Kubernetes. Now, let's switch over to a secure CRT screen where I'll show you the cluster itself. All right, so here is the Kubernetes cluster that I just showed you that I have running on a set of virtual machines. So you can see here that I've already deployed Cilium in the interest of time, and I used that very same Helm command I just covered a moment ago. So you can see that everything is up and running already in the environment. The other thing that I've already done is I've labeled the nodes with a specific moniker, BGP node, that we're going to leverage here in a moment as we deploy the BGP functionality. So let me just show you. So kubectl, get nodes, show labels. So you can see here on K1 node 4, 5, and 6, you can see they have this role BGP -node. And this is going to be important. Now, you can call it anything that you like within your environment. This is just the naming standard that I'm leveraging within the environment itself. So we're going to be looking at these 5 files that you see here on the screen. We have a file that's going to define the load balancing pool itself that we're going to be leveraging. And then we have a YAML file for how we're going to be doing the BGP announcements, the PeerConfig settings that we want, and this is specific to how it's going to be peering upstream with our physical network, and then the cluster config itself for BGP, and then some information on the L2 announcements. So I'm going to walk you through each one of these files in and of itself so that we can look at them and we can explain and understand what's in each one. So we're going to start out with this load balancing pool. So you can see the kind here is a CiliumLoadBalancerIPPool. We're going to give it a name just as you were expecting. Now, the first thing that we do here is allow first last IPs, meaning do we want to use .0 and .255? I personally prefer not to use those in my IP pools. I want things to start at .1 and end at .254. That's going to be a personal preference or an organization preference, but I've gone ahead and set that to no. And then we're going to define the CIDR that we're going to be using. So you can see here that I am going to be allocating 10.10.211.0/24 as the first IP pool. And then I've also given it a value called apps. We're going to reference this value in a few of the other files and when we start deploying applications and creating a Gateway API service. So this is the first file that we have to go ahead and apply to the environment. And then we're going to go ahead and do BGP announcements. So here you can see, or advertisement. So we've got BGP advertisement. We give it a name. Okay, we're going to advertise it, and we're going to call it BGP. All right, it's a service load balancer IP. And then again, that value, we're going to match the expression for the pool to that app's value that we've created. So once that's done, then we're going to be editing the BGP peer config. Now, this config is similar to what you're probably familiar with on the physical networking side. So we're going to set certain values like the hold timer, keep alive timer seconds, graceful restart, whether we're going to enable that or not, the number of restart time seconds in between each thing, whether or not we're doing IPv4 or IPv6. And then again, we're going to match that advertisement of BGP that we set earlier. And then the final one is the actual BGP cluster config itself. Now, this is where we're going to define how these worker nodes inside the Kubernetes cluster are going to go and connect to our upstream leaf switches. Now, in my case, I have two Cisco 3360s. They're Nexus switches that I'm using. I only have a pair, but they're essentially configured as a border leaf, each one of them up to the spine, right? So all of the north-south traffic goes directly from the leaf switches out to my pfSense firewall, which is like my top of rack or my core within my environment, and then out to my internet providers. So here what we're specifying is that we're going to do the node selector. So this is where that BGP-node is going to be used. So when we apply this manifest, it's going to only apply the manifest essentially, or run the BGP functionality on the nodes that we've labeled BGP-node. So again, I've just done that with a subset of the cluster nodes 4, 5, and 6. And then we're going to give it a name. I just call it instance, and then the AS number that I'm going to be using. And then we specify the local AS number. So in my case, we're going to be specifying this as 65011. And then the upstream AS that it's connecting to is going to be 65002 on my network. So I'm going to give my two peers, okay, so leaf switch 1A, leaf switch 1B. I'm going to tell it that the AS number on that leaf switch is 65002, and then I'm going to give it the peer address. Now, we want to make sure that this peer address is in the same network that our nodes are in as well. So 1010.210.2 and then 1010.210.3 are the two switches. And again, these are going to be configured identically 65002 on both of them. Now, some networks might differ. One leaf switch could have one AS and another leaf switch could have a different AS, and you're segmenting them off with your peering policies. I'm just keeping this as simple as possible. So once we've done this, so we're going to go ahead and do a kubectl apply, and then we're going to apply this one. What we want to make sure that we do, and I've already done this on these switches, but my leaf switches, okay, we're going to go ahead and connect to both of my leaf switches. And I'll show you where I've already configured the neighbors for the three worker nodes within this Kubernetes cluster. So we'll come over here on leaf switch 1A. We'll just do a show run. Do a show run over here. Okay, so as we switch back, so the first leaf switch will come all the way down to the bottom. So you can see here I have router BGP 65002. So there's that local AS number on the leaf switches. Okay, I've given it a router ID, and then we've configured a number of neighbors. Now, this is my neighbor up to my pfSense. So the way that I have this working, and I'll show this to you in a diagram in the video, but essentially I have my pfSense. It's peered with these leaf switches, and then the leaf switches are now peered with my bare metal cluster running Cilium. They're going to be peered with this cluster as a virtual machines. And then I also have them peered with my tier 0 inside of my VCF environment. So I have peering taking place across a number of different points or endpoints within my network. So I've got routing all the way through everything. And then that pfSense will inherit everything. So as we're first configuring the smoke test application and getting a VIP, we'll be able to go up to the pfSense and actually see that announcement, that /32 that the Gateway API is going to create, and then that the BGP policy is going to push all the way up. We'll be able to see it, and that's how we'll know it's working. So again, I've already peered the leaf switches to the pfSense, and then these other ones are, this is my bare metal cluster right here. 14, 15, 16, 17, and 18. I'm actually pairing with all 5 of my worker nodes in my bare metal cluster, which is a little bit overkill for what I'm doing, but it's how I did it initially. So here you can see, though, I've configured the first 3 worker nodes. So 1010, 210, 14, which is node 4, 1010, 210, 15, which is node 5, and 1010, 210, 16, which is node 6. And you can see I even gave them a description so that I know exactly what they are and don't get confused by it, or also so that I know which ones are easy to leverage if I go and delete this cluster later on. And then again, on leaf switch B, the same configuration exists there. We'll just focus here on these 3 nodes. Okay, so 14, 15, and 16 we see exist. Now, what we can do on this side, on the physical network side, is we can do show IP, BGP, IPv4, unicast summary. And so we can now see that we have these 3 worker nodes that they are peered. They're peered on AS65011. Okay, and then we can see that we've seen some messages already sent. We can also do a neighbor. Okay, and so we can go through here and we can find the more specific information. So here's 210.14 right here. So here we can see it. Okay, so we can see that everything is connected and established. And the thing that we're always looking for is this right here. We want the BGP state to be established. Now, you might be asking yourself or saying to yourself, Chris, I won't have access to the physical network. How do I know whether or not my BGP sessions are actually connected from the Kubernetes cluster's perspective upwards, right? So you probably have access for sure to the Kubernetes cluster where you're doing all of this. How can you make sure that these things are running? So great question. So what you want to do first is do a kubectl get pods -n kube system -o wide, because we want to see the nodes themselves. So what you want to look for is the Cilium pod that are for the worker nodes that you've specified as a BGP node. So in this case, node 5 right here is a BGP node. Okay, so that pod identifier is this one right here. So what you can do is run a kubectl -n kube system. Okay, and then exec it, and then that pod, and then you want to go, ##, and then Cilium-dbg for debug, and then BGP and peers. Okay, and so now we can see the BGP session information, or the neighbor information specifically from that pod's perspective. So here we can see local AS6511, peer AS, so the AS up on the leaf nodes themselves, 65002, the address and port, and then the session. And again, it says established here, and you can see that it's been up for a few hours already, and the IP address family, IPv4 unicast. Okay, so here, this is how you would see it from a Kubernetes perspective. Do I have BGP configured the way I would expect it to? And we're able to see here that we do, which is outstanding. So the next thing that we want to do is we want to actually go ahead and do a application deployment of some kind to be able to grab a VIP, and we want to see that VIP actually advertised as a /32 route, in my case, all the way up to the pfSense router to know that it's working. So what we want to do is I have this smoke test application. You can see here it's just a simple echo deployment, okay, echo server deployment, and then we go ahead and we tell it that we want to grab a public IP, and then we want to grab it from the pool apps that we defined in that IP pool. So we're going to go ahead and go kubectl apply -f, and then our smoke tests. So we'll let that, and so what we'll do here is kubectl get all. So we can see here the pods are creating, but we can see importantly the echo service type load balancer, and we can see that external IP. Okay, so this is the external IP that it's allocated out of the pool that we created. So 10.10, 2.11.1, Okay, outbound port 80, inbound port 31447. So what we should first be able to test is curl to that service on the node itself, or rather within the cluster. Okay, so we can see that it's working there. So now what we should be able to do is just go to our pfSense first. So here's my pfSense. Let me hit refresh. So I'm running BGP again through the FRR package, if you're familiar with it. So what we're looking for here is 10.10.2.11. Here it is, right here. So you can see here 10.10.2.11.1/32. It's finding it from the 10.1.10.2 and 10.1.10.3. So those are the administrative interfaces on the leaf switches, the other side of the leaf switches that my pfSense peers with. You can see it's coming from AS65011 via 65002 on the switches themselves. So we should be able to come here, open up a new terminal window, okay, and then we should be able to do a curl off of that directly to 10.10.2.11.1, and we can see that we are actually able to get to the service as we would expect. So this is showing us that the Gateway API functionality and the VIP allocation is happening correctly, and the dynamic routing of it is happening all the way up through our stack, from the Kubernetes nodes themselves up to our leaf switches, and then out through the pfSense or our core network, whichever it might be within your environments. So this is how simple it is to get Cilium with BGP and the Gateway API functionality working within your environments all the way. Hopefully this video has shown you how easy it is to get the BGP functionality and the Gateway API up and running within Cilium and your Kubernetes environments. Now, as we've seen, Cilium is gaining more and more wide-scale adoption. It's becoming an option for every public cloud. It's an option now in Red Hat OpenShift. It's been an option, and you've seen the video where I show you how to do it with Rancher, and you can always certainly roll your own Kubernetes, as I've done here, leveraging Cilium as your CNI. So it really is becoming an industry leader out there for organizations, not just because of this BGP and gateway functionality, but also because of the security policies that you're able to do leveraging eBPF directly inside of the Linux kernel. So in my opinion, it's by far the best choice out there for a CNI from a Kubernetes perspective. With its surrounding tools like Tetragon and Hubble, it really makes a cohesive unit for you to be able to deploy as you're looking for how to build out your Kubernetes platforms to offer them up out of your organizations. I think it's really going to give you the greatest longevity out there within the landscape. As always, I hope you've enjoyed this video. Please make sure that you subscribe to the Virtual Elephant YouTube channel, that you hit the like button, and turn on notifications. Please leave me a comment. Let me know what you think, what I can do better in the future, and how I might be able to help you both within your teams and individually as you strive to drive maturity within your Kubernetes platforms and offerings. As always, you can find me on X at Chris Mutchler, and be sure to find me on LinkedIn as well. I post there regularly, and I especially talk more about leadership style topics and how they relate to the things that I do tactically here in the YouTube channel. I look forward to talking to you next time.